Assalamu alaikum. Today I'm gonna take a class on calculating with moles. Most of the chemistry students of O level they worried about this chapter moles. Hopefully after this class they will feel it very easy. I'm gonna start the class now. So I'm gonna change the slide first. We are gonna learn these topics percentage by mass first at first. Well, in this chapter, we have to go step by step, otherwise, we will not l- be able to learn everything. So, here we will go very slow and by step progress, hopefully, we will learn everything regarding the calculation of the modes. Well, at first, percentage by mass. Percentage by mass, to calculate the percentage by mass, it indicates the amount of different component present in a particular compound in percent. For example, water is a compound, it contains hydrogen and oxygen. So how much percentage of hydrogen and how much percentage of oxygen is available in water, that we need to find it out. That is actually find percentage composition. Let's see how we can do it. So the unit of, suppose I have given an example of water, the unit of water is its molecule, and we know how to write the molecule. To express the molecule, we use symbols, which is symbols, and by combining the symbols and valences, we get the formula. So formula is the unit of water. I have given the example of water. So here it is called RAM, relative. We are AM, that is relative atomic, by using relative atomic mass of different elements present is one in water can be added to get the relative formula mass of water, which we need to find it out at first. So for doing it, we need to use the periodic table. Periodic table is a very important supporting element here to calculate the relative atomic mass of water, relative formula mass of water. I have given the example of water, that is I'm talking about water, but it can be anything, any molecule, any other molecule like ammonia, carbon dioxide, etc. So we have to find out the relative formula mass of those molecules using the periodic table. And using the periodic table and the relative atomic mass of different elements, we can calculate the relative formula mass of any molecule. For example, yeah, if it is asked to find out the percentage amount of nitrogen and hydrogen in ammonia, then how we can do it? We have to first find out the relative formula mass of ammonia, right? And if we analyze ammonia, we know the formula of ammonia, it is NH3. So first we have to find out the relative formula mass of water. We have to use the periodic table here, right? Periodic table says that hmm, one atom of nitrogen's atomic mass is 14 and hydrogen's atomic mass is 1. So one atom of nitrogen present is an ammonia, which is 14, and 3 atoms of hydrogen present in ammonia. That means we have to multiply 3 into 1, because the mass of one hydrogen atom is 1, and then when we multiply it with 3, then we will get the mass of 3 hydrogen atoms. So if we sum of these two things, like 1 nitrogen atom and 3 hydrogen atom, then you will get 17, which is the relative formula mass of ammonia. I hope you understood these things, students. If you do not understand, please let me know. Then how we can find out the percentage of nitrogen and hydrogen in ammonia? Well, in this case, we can use this formula. We have to remember the formula. The formula is we have to put the relative atomic mass at the top at the numerator, and we have to multiply it with the number of atoms of nitrogen present and divided by the relative formula mass of ammonia. Okay. So using this formula, we will get the percentage amount of nitrogen here, which is 82%. By using the same formula, we can also find out the percentage amount of hydrogen in ammonia. It is the same technique. We know the formula mass of ammonia, that is 17, that is the total mass which we have to put at the denominator. And at the numerator, we have to put the relative atomic mass of hydrogen, and 3 hydrogen atom present here. So we can multiply it with 3 into 100, as we have to convert it into 100%. So here we will get the percentage amount of hydrogen is 18% in ammonia. This type of questions usually come in the IGCSE exam or O-level exam. I hope students you will be able to solve this type of problems. Okay. So this type of problems you can practice at home. Here how we can find out the percentage amount of oxygen in these different compounds. All of these compounds contain oxygen: magnesium oxide, potassium oxide, sodium hydroxide, and sulfur dioxide. So if I ask you which substance contains the maximum amount of oxygen, to do it, you can do the calculation which we have just learned in the previous slides. So here we need the periodic table to find out the relative formula mass of magnesium oxide, potassium oxide, sodium oxide, or sulfur dioxide. And then we can use the formula. For individual compounds, we can use the individual formula. For example, in the first one, magnesium oxide, the relative atomic mass of oxygen is 16. That we know from the periodic table. We do not need to memorize it, right? So you have to put 1 atom of oxygen present. So you have to put 16 at the top, and at the denominator, you have to put the sum of the relative atomic mass of magnesium and oxygen, which will be 16 plus 24. I think 16 plus 24 will give you 40. So you have to put 40 at the denominator and multiply it by 100. Then you will get the percentage of oxygen in magnesium oxide. We can do the same thing for other compounds as well. We have already learned it in the previous slides. If you do not understand, please watch my previous slides one more time. Now, if it is asked how much nitrogen does each, nitrogen is a very important component for every fertilizers, right? So anybody can ask you which one is the best fertilizer, the one which contain maximum amount of nitrogen. Definitely we can choose that one. So to choose which compound contain maximum amount of nitrogen, we have to, maybe we will be given these following options: ammonium nitrate, ammonium sulfate, and NCO2H4, that is urea. Its chemical name is diaminoketone. So for every compound, we can find out the percentage amount of nitrogen, and the one which contain the maximum amount of nitrogen, that one will be best, right? So we have already learned how to find out the percentage amount of nitrogen in these compounds. Hopefully you have learned it from the previous slides, and you can calculate it from here. And if you do the calculation, so far I can understand urea is will be the best fertilizer, because, and the results will be like this. Why urea is best? Because it contains the maximum amount of nitrogen, which is 47%. The next one, better one, is ammonium nitrate. Left side, the commercial names are given, but the chemical names are given in the middle. First one is ammonium nitrate, ammonium sulfate, and urea. Among these compounds, urea contains the maximum amount of nitrogen. That is why it is best. I hope students you understood. So I'm gonna change this slide again. Conservation of mass. Here we can find, we need to know about the idea, we need the idea of empirical formula and molecular formula. We know that molecular formula is that kind of formula which contain the actual number of atoms present in a molecule. For example, ethane, it contains 2 carbon and 6 hydrogen atoms. So the molecular formula of ethane is C2H6, which contains the actual number of carbon and hydrogen. But empirical formula does not reflect the actual number of atoms, it rather reflects the ratio, simplest ratio. So if we do the ratio, that means if we simplify C2H6, if we divide both the number by 2, then you will get 1:3. In 1:3 ratio, carbon hydrogen ratio in ethane is made. So the empirical formula of ethane should supposed to be CH3. Here, so here you can write the empirical formula of ethane will be CH3, because if we simplify C2H6, it will be CH3, right? And empirical formula always reflects the simple ratio. So, so to get the idea about molecular formula and empirical formula, here you can solve the problem. Methane is CH4. So you can't simply simplify it, right? You cannot simplify the formula. So empirical formula will be CH4 as well. So first one will be CH4. Second one C2H6. It is molecular formula. So if we simplify it, then you will say you should supposed to get CH3, which we have just solved in the previous slide. Next one is C3H6. 8 again you cannot simplify it. Can you simplify it? No. So here the answer will be C3H8 as well. C2H4 can be simplified as CH2. So here the fourth one will be CH2. And C6H12O6, it can be simplified by CH2O, because it is by dividing all the numbers by 6, you will get 1:2:1. So it should supposed to be the second one, CH2O. So I hope you understood and you have understood the difference between molecular formula and empirical formula. Here actually start button will not work, because it works by using Adobe Flash, which does not work after 2000, which has not been working after 2020, so far I can remember. So without using the Flash features, we can use this presentation. We do not need it. Okay. Here we cannot use this start button because of the inactivity of Adobe Flash, and Adobe Flash is not working after 2020. So I'm going to change the slide now. And so here the percentage composition of a compound is given. A compound, it is said that 50% sulfur and 50% oxygen present in a particular compound. From here, how we can find out the empirical formula? This type of questions are very common in O level or in IGCSE. So let's see the technique, how we can find out empirical formula from the percentage composition. We have to use the periodic table to get the value of relative atomic mass. RAM stands for relative atomic mass. Well, so look at the first step. First, we can divide the amount by the respective relative atomic mass. For example, sulfur's relative atomic mass is 32. That we can get it from the periodic table. And oxygen's relative atomic mass is 16. So by dividing the respective amount by the relative atomic mass, you will get the mole ratio. But this is a fractional number. We have to get the whole number. So, or simple number, to get the simple mole, we can use the smaller number, and that smaller number can be used to get the simple number. By dividing both the quotients by the smaller number, we can get the simple whole number. For example, here look at the second step. Both the numbers will be divided by the smallest number. The smallest number is 1.56 between these two. So by 1.56, we can divide both the quotients. As a result, you will get the whole number, which is 1 for sulfur and 2 for oxygen. So the empirical formula of the compound is SO2. So by following these two simple steps, you can calculate the empirical formula from the percentage composition. I hope students you have understood it, right? If you do not understand, please watch the slides again and again, and hopefully by practicing it will be very easy for you. So I'm gonna change this slide again. Look at some problems, how we can find out the amounts from by using the equation, the balanced equation. It is a very important type of problems. Let's see some problems. Actually, it is a fact that according to conservation mass, nothing can be destroyed or created. If anything contains two atoms, the two atoms will also be available in the compounds, maybe in the compound form, but the nothing will be destroyed from here. Here is the example is given. You can see these two things are here before the chemical reaction. After chemical reaction, after arrow, you can see they are making, maybe they are making a compound, but both the things are available here. Nothing will be destroyed. Apparently, we may have idea that something is destroyed or something is totally newly created, but it does not happen at all. Always the conservation law of energy or mass says that nothing will be created or destroyed. Let me change the slide again. Limiting reagent and excess reagent are, we have to know the concept of limiting reagent. In a reaction, maybe out of two reactant, maybe one reactant is a limited amount, another one may be excess. So the one which will be used up after the reaction, totally used up, that is limiting reactant, and the one which will be available even after the reaction is finished, a small amount will be available, that is actually excess amount, excess reactant. So I hope you understood about limiting reactant and excess reactant. Let me change the slide. Here you can see an example is given. 28 gram of iron reacts with excess copper sulfate solution. What mass of copper will be made? For your kind information, I can tell you that every reaction depends on the limiting reactants. The amount depends on the limiting reactants. We cannot consider the excess one, because excess one, by doing calculation using the excess one, will not give you the correct result, because excess one will remain there after the reaction. So, but limiting reactor one will be used up when the limit as it is used up completely. So, if we consider the amount of limiting reactant, then we will get the correct result every time. And this, for solving this type of problems, what we have to do, we have to find out the number of moles of the limiting reactants. Okay. Then, according to using the balanced equation, we will understand what will be the amounts of other substances produced according to the mole ratio. Okay. So number we can how we can find out the mole, that can be calculated using this formula. We know the formula, right? Mole is equals to mass of the substance by molar mass. Students, maybe sometimes I am going a bit faster, but I am making this video for better for everyone. That is why I become a bit fast. If you do not understand anything, then by pausing or by watching the video again and again, hopefully you will understand. That is why I am becoming a bit fast, and maybe for some students, if I go the video using a faster tempo, maybe it is good for them. So if you are slow, then in that case you can watch the video again and again, and hopefully you will understand. So whenever you will calculate the amount using a balanced equation, you have to follow the following steps. Write a balanced equation for the reaction at first, then write down the relative atomic mass of the reactants and products. Use the balanced equation to write down the ratios of reactants and products. Convert this into a ratio of reacting masses. Calculate the scale factor and apply this to the ratio of reacting masses. Let's see the problem. Then you will understand how we can use those points. Here it is given the amount is 28 gram of iron. So the balanced equation is this one, right? Iron plus copper sulfate, you will get copper plus iron sulfate. So here the limiting the amount is iron because copper sulfate is excess. Already it is said that copper sulfate is excess. That means if one reactant is excess, then another one will be limiting. So we have to use the amount of iron given here. Copper sulfate amount is not necessary because it is excess. So we have to convert this amount of iron into its mole. For example, how we can find out the mole, for calculating mole, we need the relative atomic mass, which will be available in the periodic table. So relative atomic mass of iron is to copper is 1:1 according to this equation given. Okay. So here the amount of iron is 56 and 64 gram. This should be the correct amount. So if we divide the 28 bit by 56, you will get the mole of iron, which is 0.5. So according to the ratio, it should be 1:1. Iron is to copper, that means 1:1. So amount of copper should be 0.5 as well. As iron is 0.5, so copper should be 0.5 as well. So if the amount of copper is 0.5 mole, then we can convert the mole into mass. How we can do it, that you already learned from the previous classes, right? So 0.5 needs to be multiplied with the relative atomic mass, which is 64. Then you will get the exact amount of copper will be produced. Here actually 32 gram of copper will be produced from this problem. Students, I hope you understood. We can also solve this problem in another way. We know this formula, right? So most mass is equals to moles into molar masses. So moles of iron is 0.5. So balanced equation says that amount of copper should be 0.5 as well. So it is shown the unitary method of iron and copper. If 1 mole of iron is used, then 1 mole of copper should be formed. So if 0.5 mole of iron is used, then 0.5 mole of copper should be formed. And if you convert it into mass, then you have to multiply it with the relative atomic mass of copper, which is 64, and which will be given in the periodic table. So here 2 gram of copper will be formed. In either way, the technique is very easy. And first you have to consider which one is the limiting reactant, and using the mole ratio, you can find out the required mole of products produced. And if it is asked to calculate the mass, then you can convert the mole into mass by multiplying with the relative atomic mass. Students, I hope you understood. That's all for today. Thank you very much. If you have any question, please let me know in my next class. Thank you.